Rishan has asked, what was your budget? How much did it cost roughly to make P21?
Um, there's a lot of components in it that we kind of had around. I mean, the radio control system is kind of well over spec. I think in 2019, people commented that the radio control was a bit of an overkill. It was a bit of a sledgehammer, but it's something that we had for drones. So, it's difficult to say what the budget was, largely because there were parts around already. The motors are probably the single most expensive items. They're about £30 worth each, I think.
Yeah.
But I mean, one could argue that our 3D printer is down to Pi Wars, and that obviously knocks the budget well out of the ballpark.
Yeah.
So, I don't know. It's hard to say. I think the 3D printed parts make the thing look quite expensive, but actually, of course, it's just time and filament. So, perhaps it's not quite as expensive as it looks. I don't know.
Fair enough. What's the top speed, and did you find you had to slow it down a bit to do the camera stuff?
Yeah, so the top. I'm going to let someone else do the maths. I'm just looking it up now. So the motors are rated to do 350 RPM, and those small wheels are 66mm diameter. So someone can do the math. Yes, very much. We everything runs at, I don't know, something. When I'm doing the initial testing, I'm running at 10% speed. So P19, the 2019 robot was running motors without encoders. And what you find is if you try and set 10% speed just by varying the pulse, using a pulse width modulation system, you tend to get nothing. I mean, the motor doesn't move over friction. The motors on this one have encoders, as I've said, so they're relatively expensive motors. But it does at least allow us to tune the speed right down. So if I say 10% speed with the PID algorithms on the motors, you do tend to get about 10%. So, that system works. So, So yes, it's running very slowly, sometimes 10%, sometimes 25% is about as far as we go with it on autonomous moves. I've done some work at 40%, but you tend to get overshoots and things, and it slows it down. So, there's a balance to be found somewhere between 25 and 40%.
Yeah. Did you find the Meccano wheels have less traction and on slopes and things? And did you do anything to them to make them more grippy?
Yes, they very much have less traction. We wouldn't. I mean. The slopes and things only come to play on the obstacle courses, and of course we don't use Meccano wheels for obstacle courses.
Of course not, yeah.
But you're absolutely right. They don't grip well on slopes and things. The thing goes off target and wanders about. It's a bit of a mess if you try and use them on anything other than a flat, smooth surface. We kind of fitted them largely for Pi Noon. Because we figured that a robot that can move sideways is going to be a big benefit in Pi Noon. But I also think they'll probably come into play on the Minesweeper. If we get to play that for real, that would be lovely. We can have a go then. Our configuration then of our robot would be look very much like Blaze's system yesterday, Meccano wheels with an up-facing camera. I think that's the perfect configuration for that game. So. Cool. You'll be seeing us copying that for that game if we ever get around to playing it for real.
Oh, please! I hope we do. What is So somebody just asked, what is an IMU and what's a time of flight sensor? Can you just briefly just explain what they are?
Yeah. Okay. So an IMU. Someone asked. I saw earlier on the conversation. It's an Adafruit BNO 085 is the IMU. Someone asked what it was. It's 3 gyros, 3 accelerometers, and 3 magnetometers, I think they're called. So it works out the orientation of the robot in space. So we use it mainly for measuring the turn that the robot's made. So if sometimes we say something like turn 90 degrees to the left, and then the IMU is used to measure the turn so that the robot makes a pretty accurate turn. We can also say to it, turn to 90 degrees, like as in east. So then it will but it doesn't matter what angle it starts off at, it will go to east facing. So we use it for that, both of those kind of modes of turn. Theoretically, it could measure how far the robot is being tipped, and part of me wants to use this robot for visual slam tests, and there we'll be looking to stop the robot if it gets too far tipped over. So that sort of thing. Time of flight sensors, I believe a laser beam is shot out in front, and then the time to reflect the laser beam to reflect backwards is measured. And if you know the time and you know the speed of light, then you can work out how far away the reflective object is. And we use that for measuring distances out the front and the sides of the robot. As I said on the video, it measures the distance in front of the robot to pick up the boxes for tidy up the toys. Typically, it runs all of the time. So if the robot goes out of control, which it frequently does, it's set so that if it goes crashing towards the wall, it stops short of the wall. That works really nicely, so particularly at test speeds. So yeah, and we're using it on the maze game for the 2020 games. We had it set up for the maze, so it can drive alongside a wall and spot when the wall disappears. You know, when there's a turn in the wall, you can spot there's a big change in the distance to the side of the robot. So it's used for those kind of things. I believe Mark had a question as well. I saw come up during the conversation, which is related. Mark said, how do you use 3 of those all on one device? I'm using a Teensy 4, which has got 3 I2C buses on it.
Nice.
So there's one for each time of flight sensor. So in fact, P21 has 3 inside it. It's got the main one. It's got one in the nose, which just does those 3 time of flights. And it's got one on the back, which drives the back screen, and they're all connected through serial ports. And then that's all driven through to the Raspberry Pi. So that's how we've got 3 of them working at once.
Yeah. What software did you use for the line following, or did you just write that?
It's OpenCV. It's written so it's this custom code on top of OpenCV.
Right. Okay. Have the coloured lines been angled specifically on the garden path route? Are they all the same?
Absolutely. Yeah.
That's a bit luck, isn't it?
Yeah.
That wasn't intentional. So did you model cable routing and connector space inside the CAD model?
It's not the cables are not modeled in the CAD model, but the room for the cables is considered. I don't know if you saw that there's a strip board on top of the robot which has got the Teensy and the IMU, and it's covered in connectors. It's got 2 connectors to the front motors. It's got power supply connectors. It's got a connector to the Raspberry Pi, obviously. So what I do there is model a box, and the box is sufficiently large that it includes the strip board and all of the connectors and a radius for the cable bend. So it's kind of a bit experimental, a bit try it and see see if you can fit the cable turns into it. It's really awkward. I mean, I haven't gone to that level of modeling. I know people do, but yeah, so I've kind of done a halfway house, just model a box which covers the full extent of the problem.
Yeah. What are you, speaking of the CAD, how long did it take to draw up everything in Fusion?
I started with Fusion in 2018. In fact, PiWaz is totally responsible because we wanted to do some CAD models so that our application for the 2019 games was to a higher standard. So it was partly because I wanted to show my boys how to use hand tools, or tools very much like my father did, but I wanted to make sure that what I was showing them was current. So it seemed like a good idea to be doing CAD, and I was interested anyway. So it's been worked on since 2018, and I think the model that you saw today is number 8.
Right.
So there's been 8 versions prior.
Right.
So there's it's been an ongoing process of modeling things and then actually thinking they weren't good enough and remodeling them. So it's been And bearing in mind, I was learning Fusion as I went, so it started off pretty scrappy, and over a couple of years, I've got a bit more experience, so I can make a model of a motor, as you saw there. That was all real time, so theoretically, you could model a motor in an hour or something.
Yeah.
So it doesn't take long once you got the hang of it.
The PC you're using to run Fusion on, is that a bit of a beast, or is it sort of a?
No, it's a Dell laptop.
Oh.
It's fairly current. It's 2 years old or something like that. It's it's nothing too fabulous.
Yeah.
My son uses Fusion as well, and he's got it on he uses it on a gaming laptop, and it plainly is faster.
Yeah.
But it's perfectly adequate on my machine. It's nothing special, my machine.
So just one last question, so I think we're running out of time. How many? So you said it was version 8. Is that the number of iterations you've had of the design, or was there versions before Fusion?
No, there weren't versions before Fusion. That's the kind of number of iterations. Obviously, each one of those, there's probably 40 versions of each of those main designs. That it represents 8 restarts from scratch. But of course, you're not restarting from scratch, because when I started version 8, or the 8th iteration, I already had the motors modeled. I already had a circuit board that I thought I was going to use, or a good idea how big it would be. So, as each one goes on, you of course got much more information prior. On some of those models, for example, you don't know how big the circuit's going to be before you model it. So you're kind of a bit stuck. You kind of guess and find it's not right, and you have to change your model to adapt. So, it gets easier as it goes on.
Yeah.
But
how many PiDrogens have there been? Is it 3 or 4?
Well, we seem to use the term for all sorts of stuff. Rocket cars for Sidma's Science Festival, for example, was one of them. So that was, but well, this is kind of, well, we call it P21 because of the year now. We've given up trying to give them numbers. There was a tracked version. There was the one that did the 2019 games. There was a rocket car. There was all sorts of things like that. So my youngest son came up with a name, and we've stuck to it.